We're just going to quickly look here at how to calculate relative formula mass. So relative formula mass is the first step we have to take whenever we are calculating moles. So it's very useful if you're struggling with moles calculations. So the relative molecular mass, or the relative formula mass, depending on which one you're used to using, is found by adding up the relative atomic masses of all the atoms in the molecule. So let's take an example. Carbon dioxide consists of one carbon atom and two oxygen atoms. We can tell that's because it's CO2. So if we look to our data leaflet, to your periodic table, we'll be able to see that carbon has a relative atomic mass of 12 and oxygen has a relative atomic mass of 16. So we can write down relative atomic mass of carbon is 12, and we can write down the relative atomic mass of oxygen is 16. Now we times that by 2 because there's the two atoms, so that would give us 32 plus 12 gives us a relative molecular mass for carbon dioxide of 44. So just remember, the relative atomic mass of oxygen is multiplied by 2 because there's two atoms of oxygen in CO2. So let's look at a couple of examples. First example we'll look at here is aluminium sulfate, Al2SO4 in brackets 3. So we can tell straight away we have three elements: aluminium, Al, sulfur, which is S, and oxygen, which is O. Then if we look to our data leaflet, in our data leaflet we will see that aluminium has a relative atomic mass of 27, sulfur has a relative atomic mass of 32, and oxygen has a relative atomic mass of 16. Looking to our formula, there are two aluminiums, 3 sulfurs, and 12 oxygens. So we multiply those relative atomic masses by the 2 aluminium atoms, 3 sulfur atoms, and 12 oxygens. Work each of those out. You find there's 54 mass attributed to the aluminium, 96 for the sulfur, and 192 for the oxygens. The last step then is to add all of those masses together, so we can work out in total our R.F.M for aluminium sulfate would be 342. Our next example then, this time we have copper sulfate with 5 waters, so it's got some water of crystallization in it. So how we deal with this is we calculate our R.F.M by making sure we include in it these 5 H2O. So in that we will have copper, so there's one of those at 64. Sulfurs, we have one of those at 32. And then oxygen, we have 4 of those, each with a mass of 16. Then we come to our waters. So we have 5 times 2, which is 10 hydrogens. And we will also have then 5 times 1, so 5 more oxygens. Add all those together, will give you your R.F.M of 250. So just to recap on that, look to your formula, see what elements are present, then look to your data leaflet. In your data leaflet you'll see and look up what each element's mass is, multiply that mass, such as here, by the number of atoms present in your formula unit, then add up the total of all of your masses to give your R.F.M. If you want to practice this, here are 4 formula. If you calculate the R.F.M, pause the video, the answers will appear in 10 seconds time.